Hi viewers, this is Dr. Gunamani Jana and you are watching video with me on this machine learning some concepts. While we are doing projects based on this machine learning algorithm, we come across something like confusion matrix, precision, recall, F1 score. So these are all confusing and creates a lot of strain for understanding and also for explanations, right? So in this regard, in this video we will be explaining everything in details and we will have a thorough idea what is the things where you are using and how you are doing all the things. Fine. So before going for this confusion matrix, I will give a brief idea. I will take maximum 2 to 3 minutes for explaining where actually we need it and why we need it, all the things. See, while you are going for this machine learning algorithm, we have broadly categorized into 3 categories. One is the supervised, one is the unsupervised, and another is the reinforced. Reinforced hardly we are using here. So mainly we will be focusing on the supervised as well as some little bit to unsupervised. The supervised learning, as we understand, we take some data sets, whatever the data is available with us. So, and we take the label data set. And with this label data set, we try to train a model. Okay. So now once the training and processings are done, the model is tested by some testing data, because the entire data we divide into some testing data and some training data. So once it is okay, then it predicts the data correctly. So it is predicting to what accuracy and all things. So that is the some measures there, some prediction, some testing measures are there. So for that we will be using all these terms. Now in this supervised learning, our aim is to map input data with output data, and it is based on some supervision, and it is the same as a student is learning in the teacher supervision in the class, whatever things we see. And take some an example of supervised learning. For example, the spam filtering. So a mail is coming, it is a spam or what, you can check all the things. Now the supervised learnings can be divided further into 2 categories. One is the regression, second one is the classification. So now let us take an example. I will explain all things in details, regression and classification. Now let us take some example of the supervised learning. One is the simple learning regression, multiple linear regression, simple linear regression, multiple linear regression, regression tree, then non-linear regression, Bayesian regression, polynomial regression. These are the different type of regressions are available with us. Now I told about this the supervised learning. Now when you talk about the 2 different categories, one is the regression, second one is the classification. Now let us see what is this regression. So regression is a type of supervised learning where the algorithm learns to predict continuous values based on input features. So the x-axis we are giving some data, so it is predicting the y-axis, and the output level in regressions are continuous in values such as the stock price, the housing price. These are the things, and the different regression algorithm we are using, like the linear regression, polynomial regression, ridge regression, decision tree regression, random forest regressions, support vector regressions. These are things coming under the regression. Is it clear? Now while we are going for the classification, classification is a type of supervised learning where the algorithm learns to assign input data to a specific category. Here it is not predicting exactly continuous, but it is, say it is belongs to this class or that class, like that, to a specific category of classes based on some input features. And the output labels in classifications are discrete values, and the classification algorithms can be binary where the output is one of 2 possible classes, or multi classes where the output can be one out of several classes. And the different classifications algorithm we are having in machine learning are logistic regression, naive Bayes, decision tree, support vector, machine SVM, k nearest neighbor, or KNN. So these are the different type of things. Now what are the different type of machine learning classification algorithm? So broadly we can see these are the different type. One is the linear model, logistic regression, support vector machines, non-linear models, k nearest neighbor, SVM, naive Bayes, decision tree, random forest classification. So these are the things it is coming under that one. Then once we are going for this unsupervised learning, the unsupervised models, it can be trained using unlabeled data sets. We do not know what are these things. That is not classified or nor categorized also. And the algorithm needs to act on that data without any supervision. In unsupervised learning, the model doesn't have a predefined output and it tries to find useful insight from the huge amount of data. So this unsupervised learning data are two types. One is the clustering, second one is the dimensional reduction or dimensionality reduction. For example, some of the unsupervised are the k-mean. Previously we are talking the k nearest neighbor. Here it is k-mean clustering, a priori algorithm, a CLAD, and these are the different type of things are there. Now it is enough theory. So now let us have the idea about what is this confusion matrix, because from the name we can understand it is something confusing. Say what is that confusing we see. Say suppose this is the actual value that we are representing here, okay, and here the predicted value. That means, say for example, here you take here, suppose you are going to take based on data we want to classify a patient is suffering from corona or any virus disease or whatever things are there. Say actually the patient is suffering and it is yes positive and also is predicted positive. We call it as true positive. And actually the patient is negative, is not suffering, and here also predicted also not suffering, negative. So this is called true negative. Are you following me? So this is true positive and this is the true negative. But for example, so actually the man is not having any symptom, he is not suffering, but predicted positive. So we call it the false positive. Try to understand what I am telling that. So this positive negative name given based on this prediction. You get it now? So actual positive, predicted positive, it is called true positive. But actual negative, predicted positive, this is called false positive. Predicted positive, but that is false. Here actually it is positive but predicted it is negative, so it is called false negative. But actually negative and predicted negative, it is called true negative, right? So now it is a peculiar things you can understand now there. So the true positive is the actual prediction, true negative is also actual prediction. In case of false positive, what happens? False positive, the patient who are not having, say suppose you are going for the heart disease instead of coronary disease, I am going for heart disease. But here the patient is not having heart disease, but it is predicting, the system is predicting it is is having heart disease. So it is called a false positive. Similarly, here false negative, the patient who are having heart disease, here it is showing actually it is having, but system is predicting negative. So this is called false negative, right? So from this what we summarize, a confusion matrix is basically a technique for summarizing the performance of a classification algorithm. So in the supervised learning we told one is the regression, second one is the classification. So in this classification, so mainly we will be going for this confusion matrix. So this is a technique, this is used for summarizing the performance, right? Is it clear? Now this matrix can help us understanding what our classification model gets right and what sorts of error it makes, right? So then confusion matrix, what it compares? It compares the predicted value as well as the actual value. Okay, what is the actual data and what is the predicted, and based on that it takes a decision our model is fit or good or not, right? So whatever the measuring matrices we are using, you will be using accuracy, you will be using precision, you will be using recall, and you will be using F1 score. So these are the measuring matrices. Based on that we will be measuring everything. Now let us take some example here. For example, we are going for the classification. We cannot label it that say something like the house prediction. So if the house is at Bangalore and is 3-story and all things, cost will be 25,000. It is not like that. So only we will be classifying it belongs to class A or class B. What is class A? I do not know. What is class B? I do not know. But based on similarity, certain things will belongs to class A, and based on similarity, certain things will be there in the class B. It's clear? Now suppose from this count and other things we found that 85% of the data belong to class A and only 15% of the data belongs to class B, because it is not necessary that same proportionate 50% will be data from class A and B. It can be anything. So now assuming that here as per the count 85% of the data belongs to class A, you can see the blue color or the black color it is more and the red color it is less, circles are there. So 15% data belongs to class B. Assume that our model predicts all the class A that means out of all the blue or black whatever you see, everything is predicted properly. Then what is the then it is actually what is the percentage of data belongs to class 85. Now the accuracy is 85%. Try to understand. So now the accuracy is 85%. However, it is not portraying the reality of our data set class B. For class B, it is unable to predict properly, right? So now suppose the same thing, some infected person, that is the predicting some person is infected or not infected. It may be corona, it may be anything. Let us not talk about that corona. So now this we want to predict the person is sick or he is not sick. So suppose we have taken some 1000 of data. Okay, 1000 rows of data is there. So ID patient ID 1. So actually sick, yes, predicted sick also 1. Okay, actually sick, he is actually sick and predicted also is sick. Then it is called true positive. And it is actually he is not sick and predicted also not. It is true negative. So like that. So if you see, it is actually it is not sick, but actually it is not sick, but predicted it is sick. You got it now. So like that, this is false negative, false positive. We can actually he is sick, but predicted is not sick, 0. So in that case, like this, we can go for predicting whether the true positive, true negative, false positive, false negative. So from this, how many TP we can count, how many TN we can count, how many FP we can count, and how many FN also we can count. And this true positive TP, it is counted 30, and false positive it is counted 30, and false negative it is counted 10, and true negative also it is counted 930. And total how many? Total will be 1000, right? Because 1000 patients are there. Now how do we calculate the accuracy of these things? For accuracy, it is telling true positive plus true negative. Where is the true positive? Here the diagonal you can see it here. The true positive and true negative. So 30 plus 930, 960. What is the total? Total is 1000. So true positive or true negative by the total. So it is 960 divided by 1000. That is coming 96%. Now we say overall the accuracy of this model is 96%. But even if we are saying 96%, but what about it is only predicting the people who will get sick. Whatever the other part, it is unable to address that one. Now we have the model like this. Now how do we calculate all things? So for example, suppose we are having the confusion matrix here. The true positive is 30, false positive is 30, and false negative is 10, and true negative is 930. Okay, now we want to go for the different measures, the thing. Now first we calculate what is the precision, then what is the recall, and let us understand what is this precision. It is a statistical term that shows us how many of the correctly anticipated instances were truly positive. You try to understand what I am going to tell you. So here this is predicted, this is positive and this is negative. In the predicted, true positive is 30, and true positive and false positive, the total is 60. You got it now, because this is the predicted, positive. Try to understand. This is the actual positive is the column, first column, and predicted positive is the first row. Now what is predicted? This precision, how we calculate this true positive 30, what is predicted and actual, divided by the predicted, true and false, whatever things are there, whatever we say. So that means 30 divided by 30 plus 30, that is 30 by 60, which is equal to 50%. Clear? Now in the recall, how do you calculate the recall? Recall we calculate this. I will tell you the details, what is precision and what is recall. I will tell you with the diagram and explanation. Don't worry, just let us calculate it. So this is the formula: true positive by true positive plus false negative. So true positive it is 30 by 30 plus false negative is 10. 30 plus 10 is 40. So 30 divided by 40, it is coming 0.75. Try to understand. Here the precision was 0.5 and the recall is 0.75. Then how we calculate the F1 score? You see, what is the problem? It comes when if you observe, when the precision is less, the recall is more, and the precision is more and recall is less. So I'll show a diagram where you can clearly understand. So then how we will take that one? So if precision is more, the model is correct, or if the recall is more, the precision is, how do you, because these are all confusing. So then what you do? So for that we go for F1 score. This F1 score, it is a harmonic mean. How do you calculate that one? So F1 score, which is equal to 2 divided by 1 plus recall plus 1 by precision. So putting all the things, we get this formula, F1 score. Okay, and if you put this value there, you can calculate also what is the F1 score for that model, right? If I have not calculated, we can calculate. So this is the case when we are having only actual seek, predicted seek, whatever things are there. But in case we are going to predict, say suppose we have like apple, orange and mango, and we, so all the three fruits are there in a basket, whatever things are there, and the system, the data sets are there. The system is going to predict. Because some oranges from Nagpur, it is looking little different. Some oranges from maybe Karnataka, it will be little different. Shape will be different. Some will be purely green. Some will be orange color. Some will be green color. Whatever things are there, how do we predict all the things, and how do we apply all this? So let us see. Now same thing. So the here is the predicted class, and here is the actual class or the true class, whatever things are there, right? Now the predicted is apple and actual is apple, it is 7. That is the true, whatever we say, it is the true positive. Okay, so for apple, true positive is 7. For orange, predicted and actual, it is 2. So whatever the green color it is showing, it is the true positive for apple. Apple is true positive 7, orange true positive 2, like that mango true positive is 1. It's clear. So now from this, how do we calculate this true positive, true negative and all things? I will tell you. When we are going for this true positive, for this apple it is 7, then how do you calculate the true negative? Just you leave that row and that column, the remaining just you add it up, that is the true negative, that is 2 plus 3 plus 2 plus 1, that is 8. Clear? So this is true positive and this is true negative. Then how do you go for the false and the positive? The false positive, what you do? What is the apple is where is there? That row except that one, what are the other values are, just you add up. So 8, 9 is there. So 8 plus 9, it is 17. So this is called false positive. Similarly, while you are doing a false negative, in that particular cell, what are there in that column, to top and bottom, just add it, that one 1 plus 3, it is 4. Is clear? Now for the apple class, now we got true positive is 7, true negative is 8, false positive is 17 and false negative is 4, right? Similarly for the orange class, what is the orange class you see here? Orange, what is the true positive? It is 2, because this is the green color it is given. Then what I are going to do? We leave this row and this column. What will be there? 7, 9, 3 and 1. So that will be 7, 9, 3 and 1. So this is called the true negative. We add it, it is coming 20. Similarly, while you are going for the false positive, in the false positive, in that cell, in that row, except that one, what other things are? 3 is there, 1 is there, 3 plus 1, it is 4. This is the false positive. Similarly, coming to the false negative, in that column except that one, 8 plus 2, it is 10. Now orange class also we computed like this, right? Okay, this is the true positive, true negative, false positive and false negative. Is it clear? Now similarly we are going for this mango class. Mango class, true positive, it is 7, it is 1 here. Okay, then if you go for the true negative, then you leave this one, that means this will be there. So 7, 8, 1, 2, so you add it, it is coming 18. Similarly coming for the true false negative, false negative means here except this one, these things, and false positive, these two will be there added, right? Now getting all the things, now all the data we are having, what is the true positive for all the different, for apple is there, for orange is there, and also for mango is there. Now let us calculate the precision, the recall and F1 score for one class apple. So because the value is given, what is the precision? Precision is true positive by true positive plus false positive. Putting it, it is coming 0.29. Recall, true positive by true positive plus false negative, it is coming 0.64. That is F1 score. So that is the harmonic mean. So 2 divided by 1 plus precision, 1 by recall. So from this we get it that 2 into precision into recall by precision plus recall. Putting all this, it is coming 0.40. Okay, that means for the Apple class, the precision is 0.29 and recall is 0.64 and the F score is coming 0.40, right? Similarly, if you are calculating for this orange class, same thing we can apply. It is coming 0.33, 0.16 and here it is coming 0.22. Okay. Now for the mango class also, it is coming 0.16, 0.09 and 0.11. So this is one way. Now you tell me, suppose we go for some other, that is the micro F1 score or the macro. How do you do it? Because till now we are confusing which one we have to accept. In the micro, what we do, because when the number of classes, number of groups are there, now we know what is the true positive of all the groups. That means for the total true positive, one is for apple, one is for orange, one is for mango, total we added, that is 10. Similarly, total false positive, total false negative we calculated. Because try to understand, because false positive we are not true positive, false positive, false negative, true negative we are not using, right? So that is not used at all. So that's why these three are used here. Now what is the precision? Precision is equal to, you know, false positive by false positive, true positive, it is 10 divided by 10 plus 26, it is 0.28. And recall also it is coming 0.28. And if you are going for this your F1 score, it is also coming 0.28. You see peculiar cases. So in this case, micro F1, the precision is 0.28, the recall is 0.28, and also the F1 score is also 0.28. Now we go for the macro F1. In the macro F1, what we do? First we do find the F1 score for all the things. Say F1 score for apple is something 0.4, and for orange it is 0.22, and for mango it is 0.11. Then what we do? Then what is the total macro F? We go for the average for the 3. That means 0.4 plus 0.22 plus 0.11 divided by 3, it is coming 0.24. Okay. So this is another is that the weighted F1 score. How do you calculate that weighted F1 score? See, for example, for apple class F1 is 0.4, orange class F1 score was 0.22, and already we calculated all things. But here, why it is so important to go for this weighted? You will find that the apple, orange and mango, they are not with the same proportion. That means equal number of apple, orange, mango is not there. Apple are maybe 11, orange are something like that 13, and mango may be something different. You get it now? So in that case, if you go for the weighted F1 score, then it will be more appropriate. Then what you have done it here? So 0.4 into 11, because 11 number of apples are there, and 0.22 into 12, that is 12 number of oranges there, and 0.11 into 13. So this is the things are there. This is the there, divided by how many number? The first number is 11, second number is 12, third number is 12, 13, 11 to 13. So it is coming 0.24. Is it clear? So like this we can calculate the F1 score. Now let us understand. I told you that when the recall is less, the precision is more. You see, and the recall is in this zone, precision is here. Similarly, when the recall is here, the precision is here. Try to understand. That's why it is difficult to predict the system is best model or like that with the precision and the recall. That is the result we are going for this F1 score. And F1 score we are using all the things, and this is the formula we are using. And when we go for another thing, that is the false positive rate and true positive rate, this is the formula we are using. True positive rate is equal to true positives divided by true positive plus false negative, and false positive rate is equal to false positive divided by false positive. Because already we have all the things, from this we can apply this formula and we can get all these things like this. Now is it clear? Now how do we calculate actual practical all things? So now you understand what is recall, what is precision, and what is F1 score. But anyway, recall, precision, I will give you a diagrammatically explain all things, you can better understand and you can remember for all the times. Now let us calculate the different value of true positive, true negative and false negative based on a different threshold value. So threshold value, what is it is used actually while you are going for a model. We define a boundary. So left hand side belongs to one class, right hand side, how do we decide that one? So based on some threshold value we divide. Say threshold 0, threshold 0.1, it is threshold will be 0 to 1, say for example. And if you see, suppose I go for a threshold of 0.5 here. So true positive is 42, false positive is 16, true negative is something like that it is given. So I am taking the threshold value when it is 0.5, true positive is 42, false positive is 16, false negative is 13 and true negative is 29. So from this, if you are calculating the recall and calculating the precision and F1 score, you see it is coming 76%, 72%, 74%. Most probably it is the best thing it is coming here, because the recall is also good, precision is also good, F1 score is also good, and the true positive rate is also coming 76% and false positive rate is also coming 0.36%. Same things we can put it and all things are there. So if you see, from that, how do we calculate actually? Because I told you that from this recall and precision we cannot predict, so we have to go for the F1 score, because F1 score will give the best thing for us one. If you see the entire thing, what is the highest F1 score? F1 score it is 0.74 here. That means with the threshold 0.5, the F1 score it is coming 74%. That means if you adopt this model, this is the best suitable model, we can use it for that one. Okay, now let us have an example how we calculate the precision and the recall. I think from this example we can have the clarity. Now I am separating, if you see a tape here, that is the model. Now initially it is not there, that means the entire fruit is there on the table, I put it there. So there are oranges are there, also apples are there. Okay, now what I do, I define a model. Define a model means I classify, so left hand side should be orange and the right hand side should be apples. Okay, but actually it never comes that just to put a boundary, all things to the left will be orange and all the data to the right will be apple. It never happens like that, because there will be some outliers. Now what we see, suppose we are going for the only the apples that is in the right hand side. In the apple you see how many total items are there? 1, 2, 3, 4, 5 items there. How many apples are there? 1, 2, 3 are the apples. That means only apple predicted 3 out of these 5. Okay, the right hand side total item is data item is 5, out of that 3 apple predicted. So 3 by 5 precision is 60%. It clear? Now but if you see here, another apple is there in the orange side, that means the total number of apple is 4, out of that 3 is predicted. Get it now? Then what is the recall? So recall is equal to 3 divided by 4, it is 75%. Are you getting me? Then how do you summarize what is precision and what is recall? Precision, that is only taken from this apple side, but recall is all apples in this side and that side. That is called the recall. You can remember like this. Now suppose my model, I take some threshold, that means I am shifting the boundary here, model is coming here. Now if it is there, how many total are there? 2, and how many apples predicted? It is also 2. So 2 by 2 precision is 100% here. Then how do you calculate the recall? Recall is there, actually there are 4 number of apples, and out of that on the right side 2 are predicted correct. So 2 divided by 4, the recall is equal to say 50% here, right? Now are you following me? Now suppose the model it is shifted here, that is the based on the threshold. The right hand side there are 4 number of apples and 4 number of apples are predicted. So that is 4 by 4 precision is here, you can get it 100%, right? Now you take it here, if something you do it here like this. Now there are number of data items are 8, calculate. So 3, 4, 5, 6, 7, 8. Out of that only 4 predicted, that is apples, because apples are there only 4. So 4 divided by total item, it is 4 by 8, that is 50%. It is the precision here. Now these are the way how we can calculate the precision and recall. And I told you that from the diagram we can clearly understand, wherever the precision is more, the recall is less, and when the recall is here, so here the precision is the maximum here, but recall is very minimum here. Similarly, here the recall is maximum, the precision is less. So now we cannot simply apply because the precision is good, so the model is best, or the recall is good, it cannot be done like this. So that is the reason we are going for something like that, the harmonic mean, that F1 score is clear. And the F1 score also using the different we are using the different that is the what you call threshold, and based on that threshold, whenever we find the F1 score is the best or maximum one, then we only adopt that model. I hope this will make any sense for all these people who are watching and who are going for this type of things, especially the machine learning based projects. They can they definitely find that this will be helpful to them. Thank you for watching this video. If you have any comments, anything, please do share with me and share with your friends also. Thank you once again for watching this video.